Where should your Agentic AI applications run? The answer may surprise you. Let's talk about it. Welcome to the Cloud Computing Insider. This channel explores the ins and outs of cloud computing without an agenda or following into the narrative set by big tech marketing. We look at what works and what does not, and the actual value of this technology in a balanced and information-forward way. If that interests you, please subscribe, like, and comment. I'm your host, David Linthicum, author, speaker, and B-list geek. Let's get started. Well, the genesis of this idea for a video kind of came from lots of questions I'm getting as people are moving fast in a huge race right now to Agentic AI. They're trying to figure out the best platforms to run these systems. And obviously, the cloud is a big contender there, but there's also alternatives like we talked about on this show before, microclouds, private cloud solutions, managed service providers, collocation providers that provide great alternatives and cost-effective alternatives. And so they're going through those decision processes now. If they're going to build and spend a lot of money on building these agentic AI systems, where should these systems run? And that's really kind of what we're going to look at in this show. So have to remember that agentic AI is ultimately an autonomous AI system capable of analyzing situations and making decisions, performing actions without direct human intervention. In essence, what these are going to be groups of agents, or they can be a single agent, that have an agentic characteristic where they're autonomous agents. They're able to exist and behave using their own personas and their own pre-programmed actions. In other words, your ability to achieve a goal either as a single agent or multiple agents. The way I like to tell my students about it, you kind of think of agentic AI systems as a company. In other words, when you run a company, it has a particular purpose or a mission, and you're going to hire people that have particular skills that are able to carry out that mission. And so in other words, we have an HR director, we have someone that's in charge of manufacturing, we have someone that's in charge of sales. Well, agentic AI systems are much the same. They're agents that take on their own characteristics and they work together to some sort of a common goal. And so these are, in essence, pieces of software that run on different platforms. So because of their agentic characteristics, their ability to be divided up as agents, they can run on heterogeneous platforms. They can run across different platforms. They just have to be connected through some sort of a network so they can communicate one to another. So that's in essence what agentic AI is. And by the way, it's been evolving over many years. It's not something that's brand new. You're just hearing a lot about it now because obviously there's a lot of hype and excitement around agentic AI as it climbs on top of the whole AI explosion that's going on with the generative AI and the other things that are going on in the industry. So let's look at, now that we know what it is, let's look at where it best can run. So keep in mind that platform choice is going to be important. It's how platform selection ultimately impacts lots of characteristics of your agentic AI system. Scalability, performance, cost, and application deployment of agentic AI. Also, we have to understand it can run across different platforms. While we're looking at a single platform to run our agents, in many instances, these agents, since they're autonomous, they're able to run in a distributed fashion in a heterogeneous platforms across different clouds, different computer systems, different processors, different operating systems. So the core capabilities that we're looking for and considering what agentic needs, there's several options that are out there on the market now. We have private clouds, we have managed service providers, we have collocation providers, edge computing servers, sovereign clouds, GPU clouds, things like CoreWeave that are out there, special purpose clouds that people are able to leverage for a particular capability. And we've been talking about those a lot on this show, so I'm not going to go deep into what they are. I'm just going to go looking at how they approach the ability to run agentic AI systems and do so in an efficient and cost-effective way. So just to reiterate, some of you may be thinking that you have to pick a single platform to run all your agents on. That's not true. This is not about picking one platform or the other. This is keeping in mind that agentic AI systems can work across many different platforms where agents can run. and they're able to work together to form multi-agent agentic AI applications or groups of agents that carry out a particular mission or purpose. Agentic AI systems often distribute functions across platforms, hyperscalers, for large-scale processing, edge computing for managing real-time responses because we're able to exist close to where you're consuming the data, GPU clouds, we're able to handle intensive tasks like model training, and private sovereign clouds to store and manage more sensitive data. So you're able to use any number of these platforms that are interconnected, forming cohesive systems like autonomous supply chains, balancing scalability, low latency, security, and computational efficiency. So you have lots of choices out there. This is not about picking one platform or the other. In many cases, it can be all of the above if the particular agents are going to run most efficient for their purpose in the system on that particular platform. So these can be very complex, very heterogeneous distributed systems. So let's look at each of these platform alternatives for agentic AI systems. And we're going to start with hyperscalers. These are large-scale public cloud platforms such as AWS, Microsoft, and Google. They're the big public cloud providers have been out there forever that are controlling a large portion of the market. So some of the advantages that public cloud providers have would be extensive AI and machine learning services such as pre-built AI models, AutoML, things like that. They're able to provide scalability for large AI applications, including agentic. They're able to provide a global presence with low latency regions. In other words, you're able to work closer to a point of presence, and therefore you're not necessarily going to be worried about latency many of the times. Also, consumption-based cost, high flexibility. You only pay for what you use. They have a strong ecosystem for supporting GPUs and AI accelerators. As I mentioned all the time, they provide an easy button for AI systems, including agentic. However, the challenges would be significant. The cost scale quickly when usage starts to scale. So compute, storage, networking, egress fees, things like that. It's very expensive to run these things in public cloud providers. Data residency concerns in related industries, such as sovereign data issues where you're not allowed to transmit data out of the country. And then costs are going to be high for the development costs and high for operational costs for long-term usage. The reality is that cloud computing amongst the platform options that we have, that we're looking at in this show, and of course, your mileage may vary depending on what you're doing specifically, but generally speaking, cloud's going to be the most expensive to build systems on and the most expensive to run systems on. So next would be private clouds. They're dedicated environments within an enterprise or hosted by a private cloud provider. In other words, you're able to leverage a private cloud as a service, believe it or not. Some of the advantages would be full control over the infrastructure. You own it, you're able to see the servers, and you're able to control it completely. So enhanced security and compliance, cost predictability for steady workloads. In other words, since the cost of the hardware is a sunk cost, you know how much it's going to cost you this month, next month, the month after that. So the challenges would be limited scalability compared to public clouds because, again, if you're trying to scale up beyond the amount of hardware you own, you have to go off and buy more hardware. High initial deployment costs, you have to buy the hardware, the software, the people that are able to configure it and leverage it, and typically high development costs and moderate to low operational costs because the workloads are predictable. So private clouds are owned hardware environments. They're going to run private cloud software, which is going to be something that emulates a public cloud provider, but in a private space, providing many of the same capabilities. So that's good. And also they've advanced a lot in the last 10 years. They used to be, engineering projects, back when I was deploying them in, 2013, 2015. Now they're very turnkey. They provide the easy button for different ecosystems such as AI and agentic AI. And many enterprises are turning to them because of the cost advantage. In other words, if we're leveraging a predictable workload, we don't necessarily need this thing to scale up and scale back on a daily or monthly basis like we can do on a public cloud provider. They're a cost-effective alternative because, again, cost of hardware is going to be significantly cheaper than running it on a cloud provider or hyperscaler where you're going to pay for use. And that's where the cost comes in. So these are lower cost, capable alternatives of running your agentic AI system. So next would be managed services providers or MSPs. They are third-party providers. They offer fully managed cloud solutions tailored for AI workloads. In other words, they can provide you an environment that's tailored for agentic AI. Some of the advantages would be personalized support and optimization. In other words, you're handing the service over, the responsibility over to other people. And so it's their problem in operating the system and managing the system. They have flexible pricing with operational expenses or OpEx focus. And the challenges, however, would be they may lack access to cutting-edge GPUs or hyperscaler services. There is some vendor lock-in risk to consider depending on how they're providing their AI systems. And the cost would be moderate development cost and variable operational cost. So this is truly one of the it depends situations. It's going to depend a lot on what you're doing and the kind of deal you're able to cut with your managed service provider. Collocation providers are interesting. These are, in essence, data centers that you can rent. They host consumer-owned hardware and shared data center systems. In other words, you own the hardware, you're leasing the data center from them, and they're maintaining it. They're dealing with the power systems, the power control environments, all these sorts of things are going to be their responsibility. But this is kind of a real estate deal. You're leasing these environments. And in many cases, you have to go in there, a contract for other people to go in there and set up the hardware and maintain the hardware. They're cost effective for stable, predictable needs, workloads. They're in essence a data center that you rent. Some of the challenges would be scalability is, infrastructure limited, sometimes, in other words, you can only go up to a certain amount of hardware that you happen to own. They require significant expense for AI optimization in some cases. In other words, this is all going to be a DIY kind of thing. You're going to have to either do it yourself or find people who are going to be responsible for doing it on your behalf. And they have a high initial investment, obviously, because you're buying the hardware, but moderate operational costs. They would be very similar to private clouds. And in some instances, private clouds may run on collocation providers. And we're kind of mixing the different platform options here. But there's never going to be one situation where you're only using one particular type of platform. So it's going to be a private cloud on a collocation provider, private clouds is running on a managed service provider. Different kind of options and opportunities that are there. And again, Agentic AI is a very flexible, distributed, heterogeneous type of system. And so your options are very open in terms of where you can run, configure, and operate these agents. So next would be edge computing servers, and these are, of course, devices or servers that you own. They're able to operate at the edge closest to where the information is going to be absorbed, is going to be consumed. So they're able to deploy workloads close to the data source for real-time processing, and obviously there's a few advantages there. There's low latency for time-sensitive AI applications. In other words, we don't have to transmit the data all the way back to a centralized server to be processed or to use it for training data for AI systems. We can do so at the edge closer to where the data is going to be consumed. So therefore, you have bandwidth optimization by processing some of the data locally. It's very efficient if you have those kinds of use cases. The challenges would be normally there's limited compute power compared to centralized platforms. You're running on a device, so it's a Raspberry Pi, it's a thermostat, it's a processor that's in an automobile. Complex decentralized management, you have to maintain these devices, you have to update the firmware, you have to update the operating systems, and if you have tens of thousands of them, that can be a logistical challenge. The cost would be high development costs in setting these things up, but moderate operational costs based on the usage model. So keep in mind, many of these devices are going to be the cheapest computing power you could buy. They're going to be a $30 Raspberry Pi, for example, or some sort of low-end device that has its own processor, has its own operating system, and it has its own storage system, but it's very low cost. And the reason that's a good thing is because you're buying many thousands of these things to become your edge computing based device ecosystem. And in many cases, people like to and find it's very advantageous, certainly in an agentic AI fashion, to run agents within these edge devices. So if you have 10,000 devices in your particular ecosystem, whatever you're doing for that, for example, managing a supply chain, running a factory, things like that, then you can actually put agents in these particular devices that can carry out a particular persona at the agent level. But of course, we have to run 10,000 agents. So we have to update them, we have to maintain them, we have to secure them, we have to govern them. So all that stuff really kind of falls on the architect and the developers who are making that happen. But in some situations, it's absolutely the perfect architecture you need for particular use cases when you have a widely distributed system and where the information can be processed at the point and it doesn't have to be sent all the way back to a centralized system. So these are more efficient, they're more cost effective, but they only have particular use cases when they're going to be effective. So in other words, you don't use these everywhere, but there's certain use cases where edge computing systems, certainly agentic, would be a good option. Next would be sovereign clouds, clouds that are compliant with local jurisdictions and data sovereignty laws. They run in a particular country and they just support that country. And of course, there's sovereign clouds that run in different countries, but they're still sovereign clouds because they only support systems in that particular country. The more stringent regulatory requirements, such as you see in Europe, would be a good use case for sovereign clouds. They provide enhanced trust with specific industries such as healthcare, finance, and they know how to deal with the laws and regulations in the particular country that they exist. The challenges would be limited scalability, cost efficiency compared to hyperscalers. They may have different limited capabilities based on what they are, and they provide a subset of what the hyperscalers are able to provide. So they provide moderate development costs and operational costs. And so again, this is kind of the it depends situation. It depends on the sovereign cloud you're using and the needs of the particular sovereign cloud in terms of some of the capabilities that that cloud has. Some of them are going to have very good AI capabilities and certainly agentic AI capabilities. Many of them are not. And so there's hundreds of these things that exist all over the world. Many smaller cloud providers are sub-billion-dollar companies or small businesses, but in some instances, if you have to work in a particular region and have to deal with compliance situations, they may be a better, more sophisticated, and more cost-effective option. Next would be GPU clouds or special purpose clouds, things like CoreWeave, where they basically are clouds that provide GPU services. They're specialized cloud platforms focusing on GPU accelerated workloads. Some of the advantages would, these things are really kind of purpose-built for AI, model training and inference at scale. High performance, flexible, compute-heavy AI tasks, they're able to do that, typically at a lower cost and higher efficiency than the public cloud providers or the hyperscalers. The challenge would be it's a niche focus, may lack broader cloud integration services, so they may lack some of the ecosystem capabilities you need, such as data pipeline services, things like that. They provide GPU platforms as a service. Cost efficiency depends on the workload size and duration, and the cost would be moderate to high for development costs, variable operational costs based on workload intensity. So these things are going to be handy if for some reason you're building an agentic AI system that needs GPU services. So it does some very intense processing, such as high-end generative AI capabilities that, push toward the LLMs or, small language models that are very sophisticated and very resource intensive. These are going to be an option then because instead of paying for the GPUs as a service on the hyperscalers, which are going to be very expensive, you're leveraging a niche provider that's able to provide you with a lower cost alternative. The trade-off is going to be the capabilities for that provider. They obviously can't do everything. They're not an AWS, they're not a Microsoft, they're not a Google. They haven't spent many billions of dollars on building their platforms. And they provide a particular narrow set of services, and that's all they want to do. But sometimes that's going to be the right platform option for your agentic AI system when intensive GPU services are going to be a requirement. So I'll sum up the cost considerations. This is the cost-conscious focused platform decision. You need to figure out the platform that's going to bring the most value back to the business and the configuration of platform or platforms that are going to be the right bang for the buck. So let's go over some of the operational expense characteristics of each of the platforms. Hyperscalers, high operational costs, usage-based pricing, compute, storage, and network. They scale quickly with workload intensity, ideal for dynamic and global apps, but very expensive for long-term resource-heavy AI systems. That's why many enterprises are choosing not to go with the hyperscalers. Private clouds, moderate operational costs, fixed cost structure due to dedicated infrastructure, suitable for stable, predictable workloads with lower expenses compared to hyperscalers. So many people are leveraging private clouds because they provide just enough of the services that they need, and it's a huge discount over what you're going to pay for the hyperscalers. You own the hardware, though, it's your problem to maintain it. Managed service providers, MSPs, variable operational costs depending on the level of service that you outsource. These are going to be very variable depending on the managed service provider and who you're using it for and what you're using it for. But you're able to get efficiency gains that are able to lower expenses. And, but vendor margins can raise overall costs. You got to look at these particular managed service providers and take them on a case basis. Some of them are very efficient, some of them not so much. Collocation providers, moderate operational costs, shared infrastructure provides ultimately cost efficiency, but operational savings depends on workload stability and resource utilization. And of course, edge servers. Low, moderate operational costs. We're paying for devices that are very low powered and therefore very cheap. The costs are operationally efficient, especially for localized processing. Factory floors, transportation systems, things like that. Expenses primarily depend on localized resource consumption. Sovereign clouds, moderate operational costs. While more affordable than hyperscalers, these are still higher than purely private or co-located systems due to additional compliance and infrastructure customization. So in some instances, it's the it depends thing. You have to kind of look at the sovereign cloud you're looking to use, how much they're going to charge you, and they're going to vary a lot in their fees, based on where you are and how much and what kind of services they're able to provide. And then GPU clouds, high operational costs, optimized for GPU intensive AI, but costs escalate with sustained model training. Large-scale inference operations, long-term workloads are especially cost-heavy. Normally, they're cheaper than the hyperscalers in running the equivalent GPU as a service. So if you're just looking for a particular NVIDIA chip to leverage as a resource, these are going to be a viable option, probably more viable than some of the hyperscalers out there because they're going to be more cost-effective, but they're not going to provide the same level of services in the ecosystem. So hyperscalers and GPU clouds are the most expensive options, while private clouds, colocation providers, and edge computing servers offer much lower cost alternatives for stable or localized AI applications, including Agentic AI. So I'm giving you some general guidelines here. Obviously, what you're doing and the kind of agentic application you're building and what its purpose is and what the use cases are and what the business ecosystem is going to be like is going to be dependent on whether or not you're going to get any value out of these platforms or not. This is an architecture. You have to select the platforms, that configuration, whether it's 1, 2, 3, many different platforms are able to run your AI agents at a lower cost, but a higher value, which is able to return the most value back to the business. That's got to be the objective here. And I'm thinking it's normally going to be a mix of platforms. And while the hyperscalers may participate in some of that stuff based on their requirement, based on your requirements, in many instances, it's going to be owned hardware solutions or leased hardware solutions, co-location providers, managed service providers, private cloud infrastructures, things like that. So we're looking at kind of a change, I think, in the preferred platforms, as we move into the agentic space. No longer is it going to be kind of a knee-jerk reaction to push everything onto a hyperscaler, but it's going to be looking at the mix of platforms out there that are typically not going to be on hyperscalers as the more viable, cost-efficient solutions for agentic AI and lots of different AI workloads for that matter. So I'll summarize it again. What are the best platforms for agentic AI? Hyperscalers. They're best for large-scale global deployments requiring scalability and AI service ecosystems, ideal for dynamic agentic AI systems, sometimes such as autonomous customer support systems and global supply chain optimization. In other words, we have to have the thing running all over the world. They're going to be the quickest path to get there, and there may be a cost incentive for doing that. Private clouds suitable for secure long-term projects such as financial fraud detection or healthcare diagnostics requiring compliance and controlled environments. Again, we own the hardware, therefore it's a known quantity. And normally, if you own your own hardware versus using a hyperscaler, that's going to be significantly less expensive. Managed service providers, efficient for startups or mid-sized companies with limited in-house expertise, and they have robust AI ambitions. So we're moving all into AI, and we're trying to make running our system somebody else's problem. Collocation providers, ideal for predictable AI deployments with less critical scalability requirements, such as data batch analysis or semi-autonomous monitoring. Edge computing, perfect for real-time latency-critical AI tasks like autonomous vehicles, smart city applications, or IoT-based agentic AI. And then sovereign clouds are going to be best suited for industries with strict data sovereignty, guidelines such as government policy monitoring, AI, regional healthcare solutions, things like that, where you're going to have a lot of regulatory issues in the country that you're going to be operating in. GPU clouds, such as CoreWeave, they're optimal for computationally demanding tasks like training advanced natural language processing systems and CV models. So each platform has its own advantages and disadvantages, operational advantages and disadvantages, technology advantages and disadvantages, and cost advantages and disadvantages. Your mileage may vary, so do a deep dive and do your research on what these platforms offer, and you'll find that the more you understand about this, the better decisions you'll make. That's a long one this week, huh? Don't forget to like and subscribe and check out my other videos on this channel. Also check out my InfoWorld Cloud Computing blog and my 100+ LinkedIn learning courses. Of course, my Generative AI Architecture course out on Go Cloud Careers, and my other YouTube show, AI Insights Innovation, on the Keep Research YouTube channel. And finally, my latest book, An Insider's Guide to Cloud Computing. So until next week, you guys stay very, very, very safe. Later.